These are some of the basic differentiation rules. d dx just means the derivative with respect to x. Derivative of constant is 0. The derivative of x with respect to x is dx dx, or 1. If you ever have to do a polynomial, which would be x to the n, this is a very useful rule called the power rule. It is the power times the base to the 1 less power. What else do we have? We were given a few more in this section. The derivative of sine of x would be cosine of x. And the derivative of cosine of x was negative sine of x. And then there's the e to the x derivative. E to the x is the only one whose derivative is itself. So the derivative of e to the x is e to the x. These are some of the first differentiation rules we're going to start with. You also might need to know the projectile motion formula, which would be the position x of t equals 1/2 gt squared plus v sub o t plus x sub o. Now all of these stand for something, so I'm going to try and label them for you. That is a position or height at time t. 1/2 g, g is the acceleration due to gravity. G is either going to be negative 32 if it's in terms of feet, it's acceleration, so it's feet per second, or g might be negative 9.8 meters per second. Either way, 1/2 times negative 32 would be negative 16. 1/2 times negative 9.8 is negative 4.9. If I see this, I know it's in terms of feet. If I see this, I know it's in terms of meters. Okay, also anytime you see a sub o, like this right here, v sub o. V sub o, anytime the sub o means initial. So that's initial velocity. And x sub o, x is the height. Sub o means the initial. So that's the initial height or initial position. So I'm trying to explain what all of these mean. The other thing is x of t is usually called the position function. The derivative of position, let me make that a little clearer. The derivative of position is called velocity. And if you were to take the derivative of velocity, which happens to be the second derivative of acceleration, a position, you would end up with acceleration. So these are very useful to know. The derivative of position is velocity. The derivative of velocity is acceleration. Once we learn, these are derivatives going this way. Once we learn antiderivatives, we'll be going this direction, but that's not for a while yet. Okay, in section 2.2, the assignment's going to be, what do I have written over there? 3 to 51 odds, 95, 96, and 98. So this will be the assignment. Okay, I gave you some rules and some explanation. Here's the assignment, and here we go. The derivative can be written y prime or dy dx in this case. The derivative of all constants are 0. For number 5, you're going to do the derivative of y with respect to x, and you're going to do power times base to the 1 less power. Once you get to 7, you may have to rewrite this. Could this be called x to the negative 5? Once you rewrite it, let's see what we get. power times base to the 1 less power. I told you I'll never accept negative exponents. So that's an x to the negative 6, which simply means it's x to the 6th in the denominator. And finally, 5th root of x means x to the 1/5 power. So to find its derivative, I would do power times base to the 1 less power. 5/5 less than 1/5 is negative 4/5. So please watch how I write this. I have a 1/5. What happens to this negative exponent? It goes to the other side of the fraction and becomes a positive exponent. And that should be the derivative for number 9. If I was to take the derivative, I don't know if you're aware of this, but could I do power base 1 less power? And anything to the 0 is 1, right? So f prime of x is going to equal 1. The derivative of all constants are 0. You might have known that slope was 0 because it's mx plus b for a line anyway. Now for 13, I need to find the derivative, which will be f prime of t. Keep the negative 3 out as a constant factor. Power base 1 less power, I think that's negative 6t. What's the derivative of 2x? Well, it'd be 2. And what's the derivative of a constant? 0. So hopefully this should be the derivative for number 13. It's important to follow this process on this group of problems or in general. Rewrite, find the derivative or differentiate, and finally simplify. So since this is a process, I might separate each column. Can I rewrite this as 2/7 and call it x to the negative 4? Is that equivalent? Now I'm going to take the derivative, keeping the 2/7 out, power times base to the 1 less power. 1 less than negative 4 would be negative 5. Multiply your top times your top, and I think that's negative 8. Multiply bottom times bottom is 7. And that x to the negative 5 would move to the bottom and become an x to the positive 5. So if you follow this procedure, it truly can help. Let's take a look at one like 29. 29 is radical x over x. Do you know that you could subtract exponents and call it x to the negative 1/2? Isn't the power bigger by 1/2 on the bottom? And then if you wanted to find the derivative, you could do power base 1 less power. 2/2 less than negative 1/2 is negative 3/2. Please watch how to rewrite this. I write the negative 1/2. This means it goes where? A negative exponent means it goes on the other side of the fraction, in this case the denominator. Anyway, I hope these help. Bring in questions if you have any.